So now for the technical configurations. The residential three-phase inverter, that's the SE5K-AUB through to the SE10K-AUB, is now compatible with the SolarEdge home battery. Before you wire it, make sure that everything's all fully shut down and isolated, as well as the battery, and use the supplied MC4 connectors to wire the battery DC. There are two options to do the DC. If it's an existing installation, you'll already have the DC coming down from the roof to the inverter. And for that, you'll need to join the battery DC in the DCD before it goes into the single input into the inverter. The alternative way to do it, this is really ideal for a new installation, is you take the DC straight to the battery and then use one of our branch connectors and then take that single DC connection through to the inverter. The communication for the system is only available via the SolarEdge Home Network communication protocol, and what's really important is you make sure that you use the correct card. There are two cards available, that's the ENET-HBNP-01 and then there's the HBCL01, which is a much larger card. The larger card used to be installed on the older systems. A couple of years ago we updated all of the cards going out on the current inverters to having the dual slots, but what's really important is if you have a card with the dual slots, only use the smaller card, that's the HBNP, do not use the larger card. What's ideal is if you're going to do an installation on an existing system, because you may not know what type of board is in the inverter, just take both of the cards with you. The inverter, as it's now got a battery, has to have a meter installed, so you can use either the Modbus meter or our inline meter. Ensure that it's set up in import-export configuration and connected at the main incoming supply. Once everything's installed, go through the normal commissioning process, that's turning on the battery, then turning on all the DC isolators, and then moving the AC onto the on position, and then just do the commissioning as usual through setup. Polyphase backup solution for the home hub inverters. The residential polyphase backup switchboard is a product which is not produced by SolarEdge, but it accompanies the SolarEdge system. And what it allows for is single-phase inverters to be installed on either dual or three-phase properties and able to supply backup to any of the single-phase loads in the event of a grid failure. It needs to accompany, obviously, a battery as well as the backup interface. It overcomes backup supply limits, especially with three-phase hybrids, and it creates a lot less work in the switchboard and also greater redundancy. It's a modular, scalable system, meaning that you can start off with just a single inverter or add additional Genesis or home hub inverters as followers and install either 1 or 3 batteries on each. So this allows for the system capacity to be between 5 and 30 kilowatts. PV modules can range from 6.6 kilowatt peak to 66 kilowatt peak. The storage can go from 10 to 90 kilowatt hours. So let's look at the mode of operation. First off, on-grid. So the three-phase supply comes from the grid to the distribution board, which then supplies the three-phase loads. There's then a three-phase supply to the polyphase backup switchboard, which in turn feeds all of the single-phase loads, so those being on L1, L2 and L3. Then there's a single-phase supply which goes to the home hub inverter, and a single-phase supply which goes to the backup interface, then obviously the comms connection between the backup interface and the home hub inverter, the home hub inverter also then having a battery. Additional home hub or Genesis inverters can be installed, as well as additional batteries. Now what happens when the grid fails? When it fails, the three-phase supply is obviously cut off to the distribution board and the three-phase loads, and the three-phase supply to the backup switchboard. The backup interface loses its AC supply as well, which then in turn tells the home hub inverter to change its function from grid following to grid forming. At the same time, the polyphase backup switchboard is then bridging together all of what was the three-phase supplies to create a single AC connection. So you no longer have L1, L2, L3, they are all just a single L connection. The transition for all of this to happen is the same as any normal system using the backup interface, so it's between 2 to 3 seconds. And then when it transitions back from being off-grid to on-grid, there's a 5-second delay. The reason for that is to ensure that the phases are perfectly matched in terms of rotation. So wiring it, DC comes from the roof to the battery, use the branch connector, and then go to the single input in the DCD. If you're going to install more than one battery, again, just use the branch connectors because it makes life an awful lot easier. The PBS is 63 amp rated. Ensure that cable sizes of 25mm for active and neutral and a 16mm earth are used, with the maximum distance of 20 meters between the PBS and the switchboard. The reason these recommendations are there is on the basis of 10 kilowatt inverters being used to allow for the fault current in backup scenario to be suitable to go back to the MEN connection. The backup interface, that needs to be wired in a slightly simpler way because all it's really doing is measuring what's going on with the grid. So that can just be a 2.5mm cable to the grid ports only in the backup interface. You don't wire the loads or anything else, so it's purely just for grid monitoring. Then you need to wire the comms connection to the backup interface. For this, just wire it as normal, using the 12V and the RS485 connections. Do not use the CT connection. Then you've got the AC connection between the inverter and the PBS. For this, again, on the basis of a 10 kilowatt home hub or Genesis inverter being connected, use 10mm CSA cable with a 4mm earth and ideally a maximum route length of 10 meters. Now, as obviously batteries are being installed, meter is mandatory. You have the option of using the internal Modbus meter that's already in the DCD of the home hub inverter, but as that is default wired in single phase configuration, you'll need to connect L2 and L3 to that. So as you can see here, you can just remove the little plastic cover to be able to access the AC terminals in the meter and then wire those other two AC supplies. And as normal, you need to connect the CTs and the main incoming supply, that's the incoming supply from the grid to the main switchboard, and ensure that if you need to extend them, use a Cat6 cable. Alternatively, you can just use the inline meter and connect that either through RS485 or via the SolarEdge home network. So if you are going to then add additional home hub or Genesis inverters, you need to set these up in leader and follower configurations. So then you need to connect the daisy chain from the leader through to the second inverter, which will be the last follower, and both the leader and that last follower need to have the dip switch in them terminated so that the RS485 bus knows where it begins and where it ends. And then also, if you wanted to, you can add additional batteries to those two additional follower inverters. Once everything is installed, then just go through the normal commissioning process. So you go through, turn the batteries on, then all the DC isolator, then the toggle switch, then switch the AC on to the PBS, and then the AC on to the PBS to the inverter, and then just go through the normal commissioning process as you would using setup. And finally, you need to then wire from the PBS the AC supply to the load circuits, so they can either be segregated within the main switchboard or they can be dedicated final sub-circuit from the PBS. What is important to note though is the PBS does not have any RCDs or RCBAs inside it, so if you are using those load circuit supplies to wire directly to a final distribution circuit, it's advisable to swap the MCB to an RCD or RCBA.